You got them?
No,
Yes.
Sunday.
All right.
Okay, so my experiment was based on the Mpemba effect, which is that hot water freezes faster than cold water, which had a long history and a very debatable history as far as ancient Greece, starting with Aristotle in 350 BC. He explained the phenomenon through his theory of what he called antiperistasis, which is basically just that two opposite qualities next to each other will make the opposite quality meet with the other one much quicker than you would if they were equal or semi. And then it wasn't questioned until the Middle Ages, which Roger Bacon specifically said that through his experiments he found that hot water only freezes faster when it's outside of a vessel. And Rene Descartes, which we're talking about in philosophy, wrote in 1637 that water that had been kept hot for a long period of time froze faster than any other sort of water. And it wasn't until Newton's law of cooling in 1701, which we call now the modern theory of heat transfer, the science community dismissed all of these hundreds of years of studies as mistakes, which the science community so often loves to do. It wasn't actually discovered in certainty until a high school student in Tanzania named Erasto Mpemba discovered it by accident while trying to make ice cream. See, ice cream was made by a hot mixture of boiling milk. And at some point, he had other mixtures in his fridge that had been cooled to room temperature and put in. But there was little space left, so he was impatient and just put the hot one in there, and it froze before all the rest. So he asked his teacher about it, and his teacher completely dismissed him, said he must have made a mistake. In fact, his class kind of made fun of him for it for the rest of his high school career. And then he went to university, where a professor, Dr. Dennis Osborne, they did experiments together with milk and water, and in 1969, they published their results together. And the effect was named after Mpemba. So for my experiment, what I wanted to do is to focus on the specific parameters that I would keep controlled, because every experiment that had been done on the Mpemba effect had been done in different ways and had different results. So the parameters I wanted to focus on were the mass of the water, the shape and type of container, method of cooling and heating, and means of temperature measurement. I thought that the Mpemba effect would take place and that the hottest body of water would freeze first. What I did is that I took Pyrex beakers, 50 milliliters of water in each one, and put them in the freezer for an hour, taking their temperature every 10 minutes. I did this for different initial temperatures 5 times. And these were my results. See, the ambient temperature in the room measured 25 degrees Celsius, and the freezer measured -3, so most of them stopped at -3 after about an hour. The interesting thing was that the coldest the coldest at 4 degrees stagnated at 2 or 1 degrees for almost 50 minutes until it froze. While the ones at room temperature and slightly warmer, this would be about the temperature of hot tap water, froze 10 minutes earlier. Although they had the biggest jump in temperature, they froze around the same time as those closest to freezing. So I got a different conclusion, just like everyone else who's ever tested the Mpemba effect. So, the room temperature water froze 10 minutes before the coldest and hottest bodies of water, and it's most likely that the Mpemba effect was affected by factors that were not taken care of in this experiment. Nobody has figured out what the specific parameters are yet. And that's it.
All right. Just one question. Do you have any theory for why the Mpemba effect works out?
Nobody really does. Like, like I really did try to research, and I have more sources than when I was trying to find out what the impact effect actually was, but I didn't end up using them because a lot of them were contradictory. So I stuck with the paper and Pella and Osborne wrote together, and one scientific journal. So.
Cool. Good. Frank's got any question for me?
Why was the freezer so warm? You said it was like -3 Celsius.
It's full of freezing. It's just it was a small freezer, and we wanted to be able to have a slow freezing
Okay.
over time so that we could see without having to check every few minutes, like 1 minute.
Okay.
If you kept the beakers in the freezer and you poured water into the beakers, then they're already full, you can never change the experiment.
I don't know. Because I measured we had aluminum foil and twist ties on top of the beakers to keep the water from evaporating and losing any mass throughout the experiment. And so the temperature being taken was both the water on the inside and the outside of the glass. So there was one of them, for example, that had frozen against the glass, and we weren't able to tell that it was not the entire body of water. But we did experience something called supercooling, which is kind of something that happens when hot water freezes really quickly. It doesn't go solid right away, even though it's full of freezing. But I don't know if that answers that.
Thank you. Hurry, eat your custard.